Namaste, welcome to this video. So in this video we are going to see one more question based on the power calculation and RMS values. So here we have two problems. So the first problem is on calculating the power and RMS value for the given condition omega 1 is not equal to omega 2. So we are having the second problem which is same as the first one x of t, but the condition is here omega 1 is equal to omega 2. So under these two conditions, so what is the power and RMS, and what is the comment that we can draw from these two problems? Okay, so let us start with the problem number 1. So let us go to the next slide. So in our previous video, if you recall, so I have showed you that if x of t is equal to c cos omega naught t plus theta, for this particular form of signal, so I have showed you the average power is going to be c squared by 2. So and we have commented there, so this average power sorry so we have commented that this average power is independent of the frequency as well as phase. That is what that was the previous discussion. Now let us see the question number A in this video. So the x of t is given as c1 cos omega 1 t plus theta 1 plus c2 cos omega 2 t plus theta 2, and given the condition, so omega 1 is not equal to omega 2. So under this condition, so what is the power? Okay, so let us start with the power calculation. So what is the formula? So average power is going to be limit t tends to infinity 1 by t, so integral minus t by 2 to plus t by 2. Okay, so x square of t into dt. So this is the formula, right? So let us go to the next page. So average power is equal to, so limit t tends to infinity, so minus t by 2 plus t by 2. Of course we have 1 by t here. So what is this? X square, right? So x square is nothing but, so we have to substitute for this. So this is c1 cos omega 1 t plus theta 1 plus c2 cos omega 2t plus theta 2, correct? This should be whole square and over dt. This is looking like this is a, this is b, a plus b whole square, right? So for now what we do, so we'll leave this integration for some time. We'll keep this integration aside and we'll work with this a plus b whole square. Okay, so using this formula we can easily separate this. This is c squared cos square omega 1 t plus theta 1 plus c2 square cos square omega 2 t plus theta 2. This is a square b square plus 2ab, right? 2a c1 c2, b is cos omega 1 t plus theta 1 is a, and b is cos omega 2 t plus theta 2. So this is the the square term expansion, a square plus b square plus 2ab. Now if you see very carefully from the previous video background, so this, so let us take this integration now. So limit t tends to infinity, so 1 by t integral minus t by 2 to plus t by 2. So what is the first term we have? The first term is c1 squared cos square omega 1 t plus theta 1 into dt. So this is the first term. The second term is limit t tends to infinity, so 1 by t, so integral minus t by 2 to plus t by 2. So c2 square cos square omega 2t plus theta 2 into dt. This is the second term. What about the third term? So the third term is going to be, so limit t tends to infinity 1 by t, so 2 c1 c2 is constant, we'll keep outside, so minus t by 2 to plus t by 2. This is going to be cos omega 1t plus theta 1. The second term is cos omega 2t plus theta 2 into dt. So from our previous idea, so one can easily say, so this whatever the term is there, the first term, so gives rise to c1 squared by 2. So that was the observation we made, right? Similarly, the second term, this will lead to, so this is going to be c1 squared by 2, correct? So these are the two terms directly we can say c1 squared by 2 and c2 squared by 2. So let us go to the next page. So this is c1 squared by 2 plus c2 squared by 2. What about the third term? This is 2c1 c2, correct? Yeah, so c1 c2, so limit, so t tends to infinity 1 by t. So what is that? The term you have integral, so integral minus t by 2 to plus t by 2 cos omega 1t plus theta 1. The first term is this. The second term is cos omega 2t plus theta 2 into dt, correct? So for now, let us see, we can manipulate this. So instead of keeping 2 here, what we do, so we'll erase this 2 here, we'll keep the 2 here, okay? So now you see, so this is looking like a formula 2 cos A cos B. So what is the formula for this? The formula for this is going to be, let us keep this 2 as it is. So let us work on this third term, okay? So the third term is going to be c1 c2 limit t tends to infinity, so 1 by t minus t by 2 to plus t by 2. This is like 2 cos A cos B, cos A plus B plus cos A minus B, cos A plus B. What is A plus B? So if you use the identity now, so this is going to be, so cos A plus B, which means omega 1, so plus omega 2 into t, okay, plus theta 1 plus theta 2. So this is the cos A plus B plus cos A minus B, right? Plus cos, so let us use the different color. So let us use the different color. We'll use this color. So cos A minus B. What is cos A minus B? So this is going to be omega 1 minus omega 2 into t plus theta 1 minus theta 2. So this is the second term, right? So this is the overall third term. Now if you see very carefully, if you just split this now, so what is going to be now? If you split this, so by inspection one can tell that, so since it is an integration of cos over a one-time period, so therefore the answer is going to be 0. Even this is the case with this term also. Okay, so therefore what is the final answer now? The final answer is going to be, so c1 squared by 2 plus c2 squared by 2, correct? So this is the total power for the given signal x of t under the condition omega 1 is not equal to omega 2. So let us go to the next page. So therefore for the x of t is equal to c1 cos omega 1t plus theta 1 plus c2 cos omega 2t plus theta 2. So under the condition omega 1 is not equal to omega 2. So in this condition, what is the power we got? So power of x of t is going to be c1 squared by 2 plus c2 squared by 2, right? So if you want average RMS value, so RMS value is going to be square root of, so power, correct? So what is the observation now? So the observation is that, so if you have the two terms, okay, so of different amplitudes and different frequencies, different phases, right? So what is the condition we are posing here? If these two frequencies are different, in that case the power is going to be sum of two powers, right? So what is the sum here? The power of this is going to be, from our previous discussion, the power for this is going to be this, whereas the power for this is this, right? So therefore this is going to be, so sum of two signal power. So that is the observation we can draw from this particular question. Please note that, so this is only true for omega 1 is not equal to omega 2. With this we can readily extend this result to a sum of any number of sinusoids with distinct frequencies. Okay, so therefore, so we can extend this result. Okay, so to a sum of any number of sinusoids with distinct frequencies. Okay, so this means, so x of t now is equal to summation, so n is equal to 1 to infinity, correct? So cn cos omega n t plus theta n. Okay, so what is the assumption here? What is the assumption we are making? So this is the extension for the previous bit number a. So only assumption is, so we are assuming the none of two sinusoids have identical frequencies. So what does that mean? So what is the meaning of this? So omega n, so any two frequencies should not be same, and omega n is not equal to 0. So then what we can show so easily, so with this condition now, so one can show easily, so that a power of x of t, okay, is going to be, so 1 by 2 summation, so n is equal to 1 to infinity, correct, cn square, right, cn square. So this is the observation that we can make, and this is the extension for the question number a. I think this is clear, right? So let us go to the next bit. I think this is clear, right? So let us go to the next page and let us start with bit number b. So what is bit number b? So the bit number b is this. What is the y of t now? So y of t is equal to same as x of t, that is c1 cos omega 1t plus theta 1 plus c2 cos omega 2t plus theta 2. So, but the condition here we are posing is, so omega 1 is equal to omega 2. Okay, so in the part A, we have showed that the power of sum of two sinusoids, right, is equal to the sum of the powers of sinusoid, right? That's what we saw in the previous slide. So if you go back to the previous slide, this is what I'm talking about. Okay, we have showed that the sum of the sinusoids, so power is going to be equal to the sum of these two, right? Sum of these two signals. So now with this, now what we can do, so this is same as x of t, but with the condition omega 1 is equal to omega 2, right? So in the previous bit number a, we have showed that the power of sum of two sinusoids is equal to the sum of two powers of the sinusoids, correct? So that's what we showed here, right? That is what I'm talking here. So now let us see, so is this condition holds true for this? So what happens in this condition? Is it going to be same or is it going to be different? Okay, so let us see that. If you just go back, so because of this omega 1 is not equal to omega 2, because of these two different frequencies, so this area is going to be 0, right? That is what we showed. So this area is going to be 0, and even this area is going to be 0. But what if the omega 1 is equal to omega 2? If omega 1 is equal to omega 2, so what happens to this? So this term is going to be 1, right? So omega 1 is equal to omega 2 means this is cos 0. Cos 0 means, what is cos 0? 1. So you are left with cos theta 1 minus theta 2, correct? So what I'm telling is, so because of this omega 1 is equal to omega 2, this term is going to be 0, and we are left with only this term, and even this term is 0, right? If these two are equal, this is going to be, so cos 2 omega 1 into t plus theta 1 in theta 1 plus theta 2. So therefore this term definitely will go to 0, and whereas this term will be, so you will get the final the term as cos theta 1 minus theta 2, correct? So therefore now with this, so let us go to the next page. If omega 1 is equal to omega 2, right? So the integrand of the integrand of the, so third term, the integrand of the third term, right? So contains a constant, right? Constant. What is that value? That is going to be cos theta 1 minus theta 2. That is what I am showing here. See, so everything is same but except for this condition. So this is going to be 0, and we are left with only this term. That is what I am talking about here. If you just apply that the integration there, so that is going to be now 2 c1 c2 cos theta 1 minus theta 2, correct? So this is going to be, so as this is the final term we get, so as t tends to infinity, so if you take the integration, you are going to get this, right? So this is the third term. So what is the note point here is the observation point. So go to the next page. The observation point, the comment or observation, the important comment or observation is that we have shown so that the power of sum of two sinusoids is equal to sum of the powers of the sinusoid, right? That is what we showed. So that means, so that is if x of t is equal to c1 cos omega 1 t plus theta 1 plus c2 cos omega 2t plus theta 2. So what we showed is, so power of this is going to be c1 squared by 2 plus c2 squared by 2. So this is only true for omega 1 is not equal to omega 2, correct? Now with this, it may appear that the power of so it may appear so that the power of x1 of t plus x2 of t is p1 of t plus p2 of t. So it may appear that power of x1 of t plus x2 of t, okay, is px1 of t plus px2 of t. So it may appear like for you like this, but unfortunately this conclusion is not true. So in general, this is not true in general. So unfortunately, this conclusion is not true in general. Okay, that is what we saw in the bit number B. So even though we have two separate signals, signals x1 of t, x2 of t. So but instead of getting p1 of t plus p2 of t, you are getting some extra term, correct? So therefore, so this is in general not true. Summary is that, so if you have the two signals, c1 cos omega 1 t plus theta 1 plus c2 cos omega 2t plus theta 2. So for this we showed the power is c1 squared by 2 plus c2 squared by 2 under the condition omega 1 is not equal to omega 2. The second point what we saw is, so the same c1 cos omega 1 t plus theta 1 plus c2 cos omega 2t plus theta 2 under the condition omega 1 is equal to omega 2. So in this condition, so what we showed is, so this is going to be c1 squared by 2 plus c2 squared by 2. Along with this, we got one extra term, that is 2c1 c2 cos theta 1 minus theta 2. So this is the extra term we got. So that is what I'm telling here. So it may appear that power of x1 of t plus x2 of t is sum of the powers of these two signals, but in general this is not true. So proof for that, so this is the proof. Okay, in general, so this condition is not true. So let us wind up the video here. So next time when we meet, we'll come up with the next new question. So till then, take care. Namaste.